Welcome, welcome, welcome to Miss Lisa's YouTube channel. Everything math and science, not really. But this class is chemistry. It's designed primarily for homeschoolers, but if you like the way I explain things, you are welcome to be here. Like, share, subscribe. If I can get 1,000 subscribers, and I know I'm only at 250 now, then I don't have to record it and then upload it. I can live stream like I used to on Facebook. That's my goal. My kids say, Mom, it's not going to happen, but I can have dreams, right? All right, so what we're talking about today is chapter 4 in this book, but you don't have to have this book to follow along. And if you're doing this as a class, then there will be homework in the description. So anyway, what we're talking about is the atomic structure. So we're going to talk about the story of the atom. The story of the atom really started thousands of years ago. Well, of course, everything's always been made out of atoms, but the very idea of atoms started thousands of years ago. There was a Greek philosopher named Democritus, and he was standing on a beach, and he said, this beach is one thing, but it's made out of all these little grains of sand. I'm one thing. I wonder if I am made out of a bunch of little particles like that. And so he named these little particles atoms, atomos, and it is literally indivisible. It was that the idea that we are made out of these little particles that cannot be divided anymore. So you could say the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, atoms, for liberty and justice for all. Because atoms means indivisible. Now, later on we found out atoms can be divided, but that's what they knew about. Then we had the dark ages of chemistry, the alchemists, those kind of witches who were trying to turn lead into gold, but all in the Middle Ages and stuff. But they actually did a lot of the foundational stuff for chemistry. They came up with a lot of the lab techniques we use today, and even a lot of the glassware. So they were starting to use scientific discovery, but they were just sort of mixing in some other sort of more witchcraft sort of things. But then science moved into more the age of reason, and chemistry started to be a science where people started studying it. And I think you get to read about more chemists and the early chemists in your book. But the one I want to talk about is one named John Dalton. And he came up with what is known as the atomic theory of matter. And in theory and science, there's common language theory, which means an idea. Like, I have a theory about that, and it's just my opinion. And then there is the word theory in science, where it is used to be more like a model, and it's true, but it's something that can change. So it's called the atomic theory of matter, and it's not that it's just our opinion that things are made out of atoms. It's true. They really are. And we know we've got microscopes now where we have been able to actually see atoms, and they're little round balls, just like John Dalton said. He said that he thought atoms were, and he named them atoms after Democritus's idea. And he said that that they were like billiard balls, pool balls, that they were round, that they were indivisible, that they were the smallest piece of matter that has the characteristic of the element. So like the gold atoms are different than oxygen atoms, and all of that is true, and you can read about it in your book. Now, since John Dalton, there's been changes to it, because now we know that the atom is not really indivisible. It can be split. We've done it with bombs. And also that it is made of subatomic particles of protons, neutrons, and electrons. But he was right in that it is the smallest particle of matter that has the characteristics of the element. Protons, neutrons, and electrons are not different from one another. They're all the same. When they're combined, that's when you have the different properties of the elements. So John Dalton started figuring it out. Then the next was a guy named, then they discovered okay, a lot of times technology comes before scientific understanding. And they had made ray guns. They could, I know it sounds like science fiction, but they made these guns that they were in tubes, and they could have a beam of electrons, they could have a beam of alpha particles, helium atoms. They could, they made these beams. They didn't really know what they were, but they started testing them. And from that, they found that these beams had a positive and a negative charge, that likes repel and opposites attract, and they could get the beam to scoot depending on what charges they put around it. And then they realized that the atom did have smaller parts that made it up, positive and negative parts. And there was a guy named J.J. Thomson, and he came up with what was called the plum pudding model of an atom. Now, that is no longer a popular dessert, so let me explain it to you. It was kind of like a ball that was sort of like one substance, and that had plums in it. So he said it was like that it was just this ball of positive that had negative electrons in it. We can think of it more like a cookie, like a chocolate chip cookie. The cookie is one charge and the chocolate chips are another charge. So that was his model of the atom, the plum pudding model, because they knew that there was positive and negative, and they also knew that the total atom had a neutral charge, so they must balance out. Well, so there was a guy named Rutherford, Ernest Rutherford, and what he did is he went to prove that J.J. Thomson was right. And what he did is he used gold foil. It's like aluminum foil, but it's made out of gold, and gold can be hammered much, much thinner, to where it's only a few atoms thick, like maybe about 12 atoms thick. So he had his piece of gold foil, and he shot it with his beam of alpha particles, his ray gun, and behind it, he had glow-in-the-dark stuff. And whenever the glow-in-the-dark stuff was hit by the alpha particles, it would make light. So he was so sure that his experiment was going to be exactly prove J.J. Thomson's right. He wasn't even there when they did it. He had his graduate students in there because he thought it was going to be boring to stand in a dark room and look for flashes of light. When he shot these atoms, what he expected was what you would expect if you shot pudding. It would make a big old splat on the wall, right? But instead what he got was, as they shot the particles at the foil, it kept hitting in the same spot exactly over and over and over and over again, over 99% of the time. Every now and then it would deflect and go off, and then sometimes it would go almost straight back at them. So it was revolutionary. I don't know if you're as shocked as you should be thinking about it, but you should be very shocked, because what it showed was that the atom is mostly empty space, 99%, nothing there. And but then that there is a small core, a little nugget in the middle, the nucleus, that is dense and positively charged, because these alpha particles were positive, and they would hit that positive nucleus and be deflected or even bounced back because of lights repelling. Rutherford said it was so surprising to him. It was like taking a piece of tissue paper, shooting it with the shotgun, and the bullets, the shot, whatever, coming back and hitting you. He said he could not have been more surprised. Sorry, I'm reaching for my coffee. Extreme close up. He couldn't have been more surprised if that had happened. Now, are you shocked yet? Think about it. Everything is empty space. The only thing that's stopping this hand from going through that one is not matter, it's energy. It's the energy of the electrons. If this room, my kitchen, were the atom, the nucleus would only be as big as the printed dot on your book, a period in your book. The rest of the atom, empty space. So that's what was so shocking, is that everything's made out of nothing almost, that the atom is empty space. But then they discovered the nucleus. They knew it was positive, and so then they figured that the electrons were negative around. They still had not discovered the neutrons. Neutrons are the neutral particles that are in the nucleus of an atom, and it turns out that really that neutrons are made out of a proton and electron squished together, and that's why they're neutral. They didn't know any of this at that time. What gives the electron is so little, it is almost like it has no mass at all. It's 1/2000th of the mass of a proton. Really, all the mass of an atom is in that nucleus, because protons and neutrons roughly have the same mass, and they are what gives the atom its atomic mass, and it is what gives it its mass. Now, what determines one atom from another is the number of protons. So any atom in the universe that has 6 protons is carbon, 3 is lithium. So, and those are those solid numbers on the periodic table. It's the number of protons. Now, atoms can have different number of neutrons. It makes them heavier or lighter. It's sort of like people can be fatter or thinner, but we're still people. So when you have fatter or thinner atoms, those are called isotopes. They're types of atoms, and they're either bigger with more neutrons or smaller with less. And so when I'm getting kids to remember this, I'm always like, isotopes. And I'm making myself fat and thin and fat and thin, so that they'll remember that isotopes, they're the same, they're just different types. Now, some of these isotopes are so big or unstable that they're radioactive, which means they give off radiation. And we'll talk more about that later, a lot more. All right, so you can see in your book about gold foil experiment, about how small it is, atomic number. The mass number is adding the protons and neutrons together. And isotopes are different, have different numbers. All right, calculating the mass. All right, so that is it for this chapter for the ideas. Now, I'm going to start doing something new. And those of you who have had me for math before, for algebra, know that this is something I do, is that I will teach the concepts, and then I'll do a separate video for showing you how to use your calculator. So we're going to start doing that in chemistry. Whenever it's a math problem, then I'm going to make a separate video where I'm zoomed in. Instead of on me, it's going to be zoomed in on the calculator so that you can see exactly how to do the math. So there's going to be 2 videos really most weeks, one for the ideas and one for the math. So the homework will be in the description. So you'll be reading this chapter, you'll be doing some labs, you will be answering some questions. You might have a test, I'll have to look and see. But the homework's in the description. If you will like, share, and subscribe, I'd appreciate it, because I got my goal, 1,000 subscribers, so I can go live and not have to make the tape and then upload it. I'll see you next time. Have fun with chemistry. Science is great.